This is 5.1 integer exponents, and we're not going to talk about scientific notation. So let's just talk about if I gave you the expression x plus y plus 2x plus y, and I said simplify it, you would probably tell me to combine like terms. So an x and a 2x combined to be, there's three x's there, and you would probably tell me to combine the y's. So 1y plus another 1y means there are two y's. What if I gave you the expression x times y times 2x times y? So now my addition signs change to multiplication. Well, what's happening here? Well, I have a y times a y. How do we write y times y? We write that as y squared. And I have a 2x times an x. Okay, so it's an x times an x. That's an x squared. And taking it times 2, there's a 2 out in front. Right? So there's a difference between combining like terms. We're adding our y's. We're adding to see how many there are. And multiplying, we can only multiply the same variables, right? And if we have a duplicate, we write it as an exponent. Okay, what if I gave you the problem, I said 3 squared. 3 squared means 3 times 3. What if I gave you the problem y squared raised to the third power? What's that saying? Well, it's saying this third power, just like the second power, means take this 3, and there should be 2 of them, you should be multiplying. So this 3 is saying take this y squared, there should be 3 of them, and you should be multiplying them. Okay, so now I have a y squared times a y squared times a y squared. How many y's is that? You know, I'm not combining like terms. Y squared means y times y. This y squared is y times y. This y squared is y times y. So I have 1, 2, 3, 4, 5, 6 y's being multiplied by each other. Isn't that y to the 6th? Okay, it is not 6y. You are not combining these like terms. That's not an addition or subtraction sign. That's a multiplication problem. That's an exponent, just like 3 times 3 is the same as 3 squared. Right, y to the 6 is the same as y times y times y times y times y. All right, so we started with y squared to the third power, and we ended up with y to the 6th. So what do you notice that happened between these exponents? Yeah, they were multiplied. That's called a power raised to another power, a power to a power problem. Okay, what did we do here? When these y's were being multiplied, I had y to the first times y to the first. How did I get y to the second? What did I do with the 1 and the 1? I added them. Okay, and if I have, let's say, x to the third power over x squared, what does that look like? If I simplified x to the third, it would be x times x times x. X squared would be x times x. So just like if I had the problem 7 over 7, the 7's divide out and you get 1 over 1, or 1. The x's are going to divide out, so that x and that x would cancel. This x and this x would cancel. So what's left is 1x in the numerator. And my x's in the denominator canceled, so they won out. So x over 1, so I have an x. So how did I go from x to the third power over x to the second power to x to the first? What happened? Well, I subtracted 3, take away 2. I subtracted my numerator minus my denominator. So we have these different so-called rules of exponents, and they're not necessarily rules, they're just more or less shortcuts for what I just did. I can always simplify an expression like this. If I don't remember to take x to the third minus 2 and get x to the first because it's a division problem, I can spell it out and then from there simplify it. If I don't remember that y squared to the third power, I can multiply and get y to the sixth. I can write it out. Y squared 3 times. What does y squared mean? And how many are there? If I don't remember that y times y to the first times y to the first gets me y squared because I add the 1 plus the 1, I can write it out. So these rules are just shortcuts, they're kind of guidelines. All right, so we have a product rule, a product to a power to a power, a quotient, and a quotient to a power. We talked about product rule, we talked about power to power, and we talked about quotient. All right, so here's an example of each. I think these examples are more helpful than these variables over here. So the product rule, when you're multiplying with the same base, now the base is the bigger number, the bigger letter, and the power is the smaller, it's the exponent. When you're multiplying with the same base, you can take the powers and add them, right? Because x to the fifth means x times x times x times x times x, and you're multiplying that times x to the fourth. So how many x's total do you have being multiplied? 9. That's the power rule. Power to power we talked about. When you have one exponent, x squared, being raised to another power, what can you do with the powers? You can multiply them. So that would simplify to x to the sixth, right? I explained this earlier, but you're taking x squared multiplied by itself 3 times, because that's what the power of 3 means, and then x squared is 2 apiece. So how many x's are really being multiplied by each other? 6. We talked about the quotient rule. X to the fifth divided by x cubed. What you can do is you can subtract the numerator's power minus the denominator. So 5 minus 3 would be x squared, right? Think about it as canceling 5x's over 3x's, 1 out, or divide out those x's and you're left with 2 in the numerator. Let's talk about the product to power rule. I'm taking a product, two things being multiplied at 2 times an x, and I'm raising it to a power. When I do that, I'm sort of I'm thinking of it, this power of 3, as being on the 2 and on the x. Okay, so it's not really distributing, but you can think of it that way. So another way to think of it, if you don't remember this rule, 2x to the third power means 2x times itself 3 times. So then you have a 2 times 2 times 2, and an x times x times x. So I have x cubed. 2 times 2 times 2 would be 8. Okay, so if you don't remember these rules, I'm saying write it out the long way. And then we have quotient to a power, which is saying sort of the same thing, except with a quotient, a division problem. You have one thing being divided by another, so it's a fraction raised to a power. The important part is these parentheses. It's not the same if I don't have these parentheses. If it's x squared over 4, that's a different problem. This squared is not just on the x, it's on the whole fraction. So again, you can kind of think of it like distributing, giving the square to the x and to the 4. The other thing you can think of it is as x over 4 squared, so that's x over 4 times itself. We're multiplying fractions, so we multiply numerators, so x times x, and 4 times 4. So refer back to this chart when in doubt, but also always think of it as writing it out, writing out the exponents. Let's practice a few. So I'm going to do it both ways. I'm going to do it the long way, and I'm going to do it the shortcut way. So x squared means x times x. And I have y to the fourth, so y times y times y times y. I'm taking it times 3x. So a lot of multiplication going on here, a lot of products. So how many x's total do I have? 1, 2, 3 x's being multiplied. So that's x to the third. I have 4 y's being multiplied. So that's y to the fourth. And then I have it times a 3. So a 3 can go out in front. That's a long way to get there. Nothing else can be simplified. I can't combine my x's and my y's because they're different bases. I can't combine it with the 3. So this would be an example of a product rule. Product rule, I have everything being multiplied. So I find things with the same base and I add their exponents. So x to the second and x to the first means x to the third. I add the 2 plus the 1. And then I find my other base. Y is a base. There's no other y, so I still have y to the fourth. And 3, there is no other number to multiply it with, so I just have a 3 to the first. All right, let's go over this next one. Here I have a power being raised to a power, so I can follow my power rule, but let's write it out the long way. First, negative 2 times y squared to the third power, so I have 3y squares, which means I have y times y, y times y, and y times y, all being multiplied by negative 2. So I have negative 2, and I have 6 y's being multiplied. That's the long way to think about it. The power rule says, if you go back and look at your power rule, the third one, power to a power, means you can multiply those exponents. So y to the second and y to the third means multiply the 2 and the 3 on the y only, not on the 2. Negative 2, it's only on the y. That's the only thing in parentheses. So y to the 6 being multiplied times negative 2. That's different than this one. What's different is the negative 2 is outside the parentheses and now it's inside our parentheses. So that means I'm taking negative 2y squared, that whole thing 3 times. Okay, and here I was only taking the y squared 3 times and the negative 2 is out in front. So I have y times y times y times y times y times y, so that's 6 y's being multiplied. A negative 2 times a negative 2 would be a positive 4 times another negative 2, so that would be a negative 8. So different, or the parentheses cause a different answer, right? And if you remember, this is a product to a power rule. This would be like number 2, product to a power, because in my parentheses, I have 2 things being multiplied, a negative 2 times a y squared, and then they're being raised to a power. So think of it as this negative 2 being cubed and this y squared being cubed, kind of like I said, almost like a distribution, but not really. So negative 2 cubed means negative 2 times negative 2 times negative 2. So that's how I'm getting negative 8. And this is a power to a power, which we just worked on. A power to a power means you can multiply those. If you don't remember that you can multiply them, write it out the long way. So y squared 3 times would end up being y squared times y squared times y squared. So there's 6 of them. That's how I'm getting y to the 6. All right, on this next one, let's write it out the long way and then talk about the rule. So I have 3 times x squared, which means x times x, being multiplied times negative 5x raised to the cubed. So that's negative 5x 3 times. All right, so how many x's are actually being multiplied here? So I have 1, 2, 3, 4, 5 x's being multiplied, so that's x to the 5th. I have a negative 5 times a negative 5, so that would be 25, times another negative 5, so that would be negative 125. A negative 125 times the 3, remember we can just multiply numbers, would be negative 375. Okay. Thinking about it in terms of rules, I have 3x squared being multiplied. I have a product negative 5 times x to a power. Product to a power is rule 2, which means they both get that power. So a negative 5 gets the cube and the x gets the cube. Well, negative 5 cubed is negative 125. Then I have x cubed times 3x squared. So multiply the 3 times negative 125 and you get negative 375. And I have an x squared times an x cubed. An x squared times an x cubed. That is a product rule. When you're multiplying same base, different powers, you can add the powers. So that's how I get an x to the 5th. Let's look at some division. Let's talk about it the long way. So 14a to the 5th means I have 5 a's there, b to the 3rd, 3 of them being multiplied, 7a squared, and b squared. So let's cancel out what can be canceled. These a's and these a's, this b and this b. So what I have going on here is 14 in the top, 7 in the bottom. I have 3 a's being multiplied, so that's a cubed. Another b up top being multiplied, so that's 1b. But 14 over 7 is a fraction that can be simplified. 14 divided by 7 is 2. So I have 2 over 1, a to the cubed, to the b. Now, let's do the shortcut way. We can either subtract or we can ask ourselves, where are there more and how many? So let's start with, let's do the subtraction. So I'm going to keep my numbers and subtract my upper exponent of a with the 5 with the lower exponent of a, which is a 2. Take my base of b, this exponent in the top is 3, and I'm subtracting it with the bottom exponent, which is 2. So I'd get 14 over 7, which simplifies to 2. And a to the, what's 5 minus 2? 3rd. B to the, what's 3 minus 2? 1. All right, let's go to the next one. X squared over 2y cubed. So let's talk about what it means to write it out the long way. X squared over 2y cubed, which means I need it 3 times. Cubed means times itself 3 times. So in the top, I have x squared times x squared times x squared. That means x times x times x times x times x times x. That's 6 x's. I have 2 times 2 times 2, which is 8. Y times y times y, which is y cubed. Okay, if you didn't remember that, this is a quotient to a power rule. I have a division going on with a power outside of it. Division going on with a power outside of it. So what can I do? I can somewhat distribute that 3. So x cubed is being, or x squared is being cubed, and 2y is being cubed. A power to a power means I multiply, so 2 times 3 is 6. And then I have a product, 2 times y, to a power. So that 2 is being cubed, so I get 8. And that y is being cubed, so I get y to the 3rd. Remember, 2 cubed is not 6. 2 cubed means 2 times 2 times 2. So I get the same thing.